Now we're going to be talking about graphics with matrices or functions actually that carry units. The example I'm going to talk about here is the case of projectile motion, where the separate movements of all the x and y vectors or positions, are given by these two equations, the well-known equations of projectile motion. The first example, we're going to use units of the international system. We have the initial position, initial velocity with initial inclination, and gravity given by the standard constant available in the units of the SMAT Studio. If I type '(g.e) equal, I get this constant as part of the SMAT Studio, and I have assigned it to the variable g here. And then I'm going to define a function f1 of t corresponding to the x, and then a function f2 of t corresponding to the y. To produce a plot, I'm going to produce a range of values of time, and so to do this, I do tt column range parentheses 0, 5, 0.1. Then I do spacebar to get the entire right-hand side vector multiplied by seconds to give me my vector in seconds. I'm going to do Control Z here to backtrack. I'm sorry, I'm going to delete these two terms. So this is what I have produced right here. Now, if I want to produce my x coordinates, I do f.1 apostrophe, parentheses tt spacebar, and then I use my vectorization function here in the matrices panel, and that will give me values of x. Of course, it's going to give me the values for storage purposes in meters, although in the future we're going to be talking about using feet. Let's do Control Z to reduce that. This is repeated, so I'm going to delete it. And I have these two expressions where I calculate x and t. Now I have calculated the position of x and y, and I can produce a matrix mxy augmenting xx to yy. And in order to produce a graph, I'm going to estimate or calculate the minimum and maximum values of x, minimum values, maximum values of y, which allow me to produce an xy plot graph with x values between 0 and 90 and y values between -60 and 20 to enclose all these minimum and maximum values. Then I simply type mxy. Now, this works fine when you're working in the international system, because the units that you have in your matrix are in the basic units of the international system. But if you're working with units of the English system and define your functions and do all the calculations just like we did before, we find that when evaluating minimum and maximum, we end up with meters. Then we convert to feet. Remember, to convert to feet, simply type on this placeholder and type apostrophe ft. And that's how I get this result. So I'm going to try to use those as my limits for x, right, between 0 and 80 to enclose those values, and y minus 90 to 10. Except that when I put mxy here, I get a graphic that doesn't cover those ranges. The reason is that my data is in meters and these positions are in feet, and so they're incompatible. In order to produce the right plot, what you have to do is take this matrix mxy and divide it by quote ft. And I'm going to do it right here because it's divided by apostrophe f. Sorry, mxy divided by apostrophe ft. And then you get the right graphic. And so be careful with when you use data in matrices or in functions in plots. If you are plotting two different quantities in the columns of the matrix, in order to produce the right graph, you want to reduce each one of them separately by the appropriate unit, time in seconds, position in feet. In here, I'm just describing the behavior of the vertical distance y as a function of time. And in that case, my matrix is already dimensionless and it's going to give me the right the right graph in feet for y and times in seconds. If I had not scaled down the units, then this is what I'm going to get, which is different than the actual graphic that I produced. Now, suppose that we don't have a matrix, but we have an equation like this one, where it's going to give me the vertical position as a function of time. I could just type F2 of TFS. I'm going to show you here how the steps. I'm going to do Control copy, Control V, and delete this here. And then I type F2 of T. If I do that, nothing's going to happen because T needs to have units of time in order to produce results for F2. So I can say times apostrophe S. And now I get a graph. But the graph is wrong because this is in meters and my data here is in feet. And so if I divide this whole quantity by apostrophe FT, then I get the right graph. One more example. If we take this component of projectile motion, solve for T from this one, and plug it in here and in here, I get this result, except that I'm missing a square in here. That's the equation of the parabola that describes the motion. And I'm going to make it a function of x, so I can plot the graphic. And so the way that you would proceed is after you have determined the minimum and maximum values where you're going to plot your scales, you proceed to type F.2 parenthesis T, and x. But that, of course, is not going to produce any result because the x needs to have units and the x needs to be multiplied by apostrophe ft, which is feet. Still, it won't show up because you need to scale it by dividing by apostrophe ft. I'm going to do a recalculate page in here. Oh, of course. It's F, not F2, so I get this extra 2 here. I'm going to go to the right, delete. Recalculate. Well, let me pause this. Something went wrong with the previous steps. I'm going to do Control C here. I'm going to paste it right here and remove the entry here. So this is the raw graph that you're going to populate by typing F of X. When you type F of X, you get nothing in there. And then you click to the right of the X times apostrophe FT. And then it gives you something different than we should be getting. That's because this thing needs to be divided by apostrophe FT. And now you get the result that we expected. And with that, I'm going to conclude this particular video. And I hope you learned something about the use of units in matrices and graphics.